Let's start with me asking you, what is 2 times 2 times 2 times 2 all over 2 times 2 times 2? Well, you might stop for a bit, then realize that when you have a fraction, you're essentially dividing. You're dividing the top from the bottom. So I'm actually going to write that down because that's really important. Fractions equals division. So I can take the numbers on the top and the numbers on the bottom, and I'm going to cancel them out because they're dividing. So once we cancel out all the 2's that we can, we realize that we only have a 2 on the very top. That's it. So this whole thing, 2 times 2 times 2 times 2, all over 2 times 2 times 2, that whole thing is equal to just 2. But I want to call your attention to the fact that we have 2 to the power of 4 on top in blue, and 2 to the power of 3 on the bottom in this tan color. And we have 2 to the power of 1 on the side as well, because 2 by itself is 2 to the power of 1. It's no accident that when the base is the same and you're dividing, you can simply subtract the exponents. Notice how I'm subtracting the 4 minus 3 to get 1. Today will be the second part of our two-part lesson. Yesterday we learned the product rule, which tells us how to multiply numbers with the same base. As we see here, we have 2 to the power of 4 times 2 to the power of 3. We can simply add the exponents together. So we have 4 plus 3, which are the exponents. We add them together to get about 2 to the power of 7, which is equal to about 128. Today, I'm going to flip that by looking at the quotient rule, which tells us how to divide numbers of the same base. I have 2 to the power of 4 over 2 to the power of 3, which we just saw in that earlier example. I'm going to subtract the exponents here to get 2 to the power of 4 minus 3, which is equal to 2 to the power of 1, which is the same thing as 2, because that's 2 multiplied by itself one time. Similar to how we add the exponents when we multiply, we're going to subtract the exponents when we divide. Okay, when I see a big fraction like this, my first instinct is to separate. So I'm going to draw in blue what I think should be the first fraction. I'm going to draw in tan what I think is the second fraction. The reason why is because of the fact that I see the same base of minus 3 and 4 on the top and bottom. So I'm going to separate this into two different fractions, minus 3 to the power of 5 over minus 3 to the power of 3 times 4 to the power of 3 over 4 to the power of 1. The reason why is because after we separate like this, it makes it a lot easier for us to use the quotient rule. We subtract 5 minus 3 as the exponent of minus 3 and 3 minus 1 of the exponent of 4. After I do that, what I'm next going to do is I'm going to subtract 5 minus 3 to get minus 3 to the power of 2 times 4 to the power of 2 as well, because that's 3 minus 1. Finally, I'm going to multiply that out. Minus 3 to the power of 2 is minus 3 times minus 3, that's 9. 4 times 4 is 16. That together is 144. Now, I'm going to write it again in the box up there as I kind of go over again what I just did. I took a big fraction and I separated it into two smaller fractions. That allows me to use the quotient rule and subtract the exponents to get my answer. So I'm just going to check to make sure I'm doing this correctly. So I have minus 3 to the power of 5, which is equal to about minus 243. 4 to the power of 3, which is equal to 64. Minus 3 to the power of 3, which is equal to minus 27. And 4 to the power of 1, which is equal to 4. I multiply minus 243 times 64 on top, and I divide it by minus 27 times 4. When I do that whole thing on the calculator, I get 144 as my final answer. One last example problem. I have 32 over 2 to the power of 2. Some of you might think, oh, that's 2 to the power of 2, that's 4. So it's very simple. Actually, I'm going to show you a more complicated way because that's going to make it easier when we do harder problems that look like this. I start by noticing that 32 is the same thing as 2 to the power of 5. So I've substituted that in and I've changed it to 2 to the power of 5 over 2 to the power of 2. Now, why did I do that? I did that because I want to use the quotient rule. Because as you know, the quotient rule only works if the base is the same. That 32 doesn't work. We have to turn that into a 2. So that's 2 to the power of 5 over 2 to the power of 2, which is the same thing as 2 to the power of 5 minus 2, because we're subtracting the exponents, which gets 2 to the power of 3, which gets 8. So let's double check to make sure we're on the same page. I noticed that, 32 is 32. But I also notice that 2 to the power 2 is equal to 4. So that's why I have 32 over 2 to the power 2, which is equal to 32 over 4, which is equal to 8. We're almost done. When you divide a number y from a number x, you are finding their quotient, x over y. So that's why we have something called the quotient rule. And lastly, let's just stamp the learning really quickly. If you are dividing two numbers with the same base, then you can just subtract their exponents. So notice here that 4 has the same base as itself on the top and bottom. So I turn that into 4 to the power of 4 minus 2, which is equal to 4 to the power of 2, which is equal to 16. Finally, sometimes numbers of the same base are hidden. We saw this with the product rule as well. So 16, that's 2 to the power of 4. So after I do that, I can turn the base into the same to get 2 to the power of 4 minus 2, which is equal to 2 to the power of 2, which is equal to 4. We've covered a lot of material so far, but you've learned a lot so far as well. We went from knowing nothing about exponents to knowing how to multiply and divide them as well. Great job. Good luck. Like, comment, and subscribe. See you tomorrow.
I'm right by your side, baby.